Hi. So here we on chapter 10, section 2. It's about the area and parametric curves. So basically here in general, when you try to find the area of the region bounded by the function y equals f of x with the x-axis between x equals a, x equals b, usually we use the integral from a to b of the function f of x dx to find such an area. But this is a function, y is a function of x. We want to do the same thing, only in this time we have the function that is given to us is given in terms of two parametric equations. So this curve is given in terms of, it's a parametric curve. So you have two parametric equations. The first one is x equals f of t, and the second equation is y equals g of t. And the parameter t is between alpha and beta. So we have the same region here, and we want to find its area. Only there's a difference here. It's we're not dealing with a function of x. We're dealing with two parametric equations that describe the given curve. So the point is to find the area of this region. What we're going to do is basically integrate from alpha to beta, because the parameter, so this is the parametric equation, x equals f of t, y equals g of t, and t is the parameter that is between alpha and beta. So when you try to find this, the area of such a region, you will integrate from alpha to beta. You're going to integrate the g of t times f prime of t dt. Now we put the absolute value bars. Basically the absolute value bars are there just in case you get a negative number, then you make it positive. So the absolute value will make it positive because the area is always positive. So as you can see here, the second integral is you start from beta to alpha. So that's why it's important to have the absolute value bar. Okay, so a kind of if you have a negative area, let's say you integrate, you get -5, then the absolute value of -5 is 5, for example. So this is the area that if they give you two parametric equation, as you know, g of t is actually y, and then f prime of t dt, that's when you have the derivative of x, which is x prime of t, which is f prime of t. So let's look at an example. Find the area under the curve. So they give us this. The curve is given by two parametric equations. X equals 2 times quantity t minus sin t. Y equals 2 times quantity 1 minus cosine of t. And they say that the parameter t is between 0 and 2 pi. So the first one, so x is f of t, y is g of t. So we know the formula is the absolute value of the integral from alpha to beta of g of t times f prime of t dt. So in this case, alpha is 0, beta is 2 pi. So you can integrate from 0 to 2 pi. You will integrate the g of t, which is 2 times quantity 1 minus cosine of t times f prime of t. So you're going to take the derivative of x. Okay, it's going to be the derivative of 2 times quantity t minus sin of t prime, and then dt. Now, when you take the derivative of t, you get 1. You take the derivative of sin of t, you get cosine of t. So So these two quantities are the same. So you can take 2 times 2 is 4, bring it outside because it's a number. Then you have quantity 1 minus cosine of t times quantity 1 minus cosine of t. You can FOIL it out. So when you FOIL it, you get 1 minus cosine of t minus cosine t plus cosine squared t. So these two give us negative 2 cosine t and then plus cosine squared t and a plus 1. That's what you're going to integrate. But we can integrate 1, we can integrate 2 cosine t, but we cannot integrate cosine squared t yet until we change it to 1 plus cosine of 2t over 2 using what we call the double angle formula or double angle identity. So we're going to replace cosine squared t by 1 plus cosine of 2t over 2. Divide both the numerator by 2, you get 1 over 2 plus cosine of 2t over 2. Plug them into this expression, replacing cosine of t squared. So from here we add like terms. We have a half and 1 give us 3 halves, minus 2 cosine t plus cosine of 2t over 2. Now we can integrate. So when you integrate the 3 over 2, you get the 3 over 2t minus, when you integrate cosine t, you get sine t. When you integrate cosine of 2t, you get sine of 2t over 2, and then times 1 over 2. So you evaluate in 0 and 2 pi. So first you plug in 2 pi for t. Wherever t is, you put it 2 pi. Okay. And okay, so what I did was I evaluate each term. So I evaluate the first term at 2 pi, and then minus this, the second, the same term evaluated is 0. Same thing here, 2 times sine of 2 pi minus sine of 0, plus 1 over 4 times sine of 4 pi minus sine of 0. Sine of 2 pi is 0, sine of 0 is 0, sine of 4 pi is 0, sine of 0 is 0. So all of this give us 0, except here you get a 3 over 2 times 2 pi. Simplify it to you get 3 pi. 3 pi times 4, it gives us 12 pi. That's the area. And the area of that region that was described. The second example, they give us cosine of x equals 2 cosine t, and then y equals 2 sine t. And those are the two parametric equations describing that region, and the parameter t is between 0 and pi over 2. So definitely alpha is 0, beta is pi over 2. So the first x is always f of t, y is g of t. So this is the formula. So we know g of t is a 2 sine t, which goes here. F prime of t, so we're going to take the derivative of 2 cosine t, which will give us negative 2 sine t. We put the absolute value bars. We take 2 times negative 2 give us negative 4. Absolute value of negative 4 is 4. So we can move it outside. And then we have sin t times sin t, which gives us sin squared t. So we have the integral from 0 to pi over 2 of sin squared t dt. Since you have sin squared t, you will have to replace it with 1 minus cosine of 2t over 2, which can be written as such. So after your replacement, substitution, you get 1 over 2t, you get 1 over 2 minus cosine 2t over 2. That's what we're going to integrate. When you integrate 1 over 2, you get 1 over 2t minus. Use substitution, give us sine of 2t over 2 for the integral of cosine of 2t, and then times 1 over 2, which give us 1 over 4. So then we evaluate the first expression at pi over 2 minus evaluated at 0, minus 1 over 4 times. We evaluate this at pi over 2 minus the same sine of 2t evaluated 0. Sine of 0 is 0. Sine of pi is 0. So this is 0. And the contribution comes from here. So 1/2 times pi over 2, which is give us pi over 4 times 4, give us pi. So this is area. So this same problem is solved using geometry. X equals 2 cosine t, y equals 2 sine t, when t is between 0 and pi over 2. This is the quarter of the circle with radius is a 2, because you can see the radius is 2 there. And its equation, the equation of this circle is x squared plus y squared equals 4. But how do you find the area of this pi? So this is quarter of the circle. How do you find it? We know in general to find the area of the entire circle, we usually take pi times r squared. Okay. But because this is just 1/4 of the circle, so it's going to be pi times r squared divided by 4. The radius is a 2, so you're going to have 4 times 2 square over 4, which give us just 4 times 2 square over 4 times pi. It just gives us pi after simplification. So using geometry, we get the same answer as using integration. Thank you.